Lesson 5, topic slope, learning target. I can identify types of slope and find slope from a table and a graph. First off, slope is the rate of change, and it describes the steepness of a line. So we have different types of slope. So we have our positive slope, which is uphill. So if you were looking at the graph from left to right, we're going up the mountain. If you had a person here at the bottom, they would be going up. And then we have negative slope, which is downhill. Then we have zero slope, which is just a horizontal line. So that's one of our special case lines. And it just goes straight left and right. And then we have slope is undefined. We can't actually define the slope because it's just a straight vertical line. If you were to think of like a person trying to walk down that, they wouldn't be able to walk down it because it's just straight down, so they just fall and go flat. Here's a visual to help you remember if you need. It's called Mr. Slope Guy. So we have our positive slope and then our negative slope. So it's that visual picture. And then we have the horizontal zero slopes. We got the little circles on the side, so it's 0. And then we have the up and down for the nose, and there's this U shape right here, so we have undefined. So if that visual helps you, feel free to use it. If it doesn't help you, just don't use it. Couple different real-life examples of slope. There are signs on the road that talk about the slope or the grade of the hill. So that slope is 26%. So this means if you travel 100 feet horizontally, you will be ascending to 26 feet vertically. So those signs are to help trucks that are big and carrying a lot of weight know if they can travel down that hill or not with the amount of weight that they're carrying. Another example is roller coasters. So when they create roller coasters, they have to use slope in order to calculate how high the roller coaster can go and at what speed. And then we also have the Leaning Tower of Pisa. You can use slope to calculate how far it's leaning. So there's different representations of linear functions. One of our representations is a table. And we've worked with completing tables in this unit. So we're going to practice finding slope. So this shouldn't look super different because we've done it in class a couple times. But to find the slope, we want to find our change in our y values and find our change in our x values and make it into a fraction. So slope is a number, and that number can be positive or negative. Sometimes it will be 0, and sometimes it will be undefined. So we're going to find that number. So we're going to look at our x values over here on our table, and we're going to see how much they change by. So we see we're going from -2 to 1, so that's +1. Going from -1 to 0, that's +1. 0 to 1, +1. 1 to 2, +1. And then we have our y values. So we have -3 to -1, that's going up by 2. -1 to 1, that's going up by 2. 1 to 3, that's going up by 2, and 3 to 5, that's going up by 2. So then I just write that as a fraction. My change in y goes on the top, so that's 2. And then my change in x is 1. So we have the fraction 2 over 1, which actually reduces to 2. All right, so let's do another example. We have our x and our y. So we don't actually have to do all of the changes in x's and all the changes in y's. We can just pick 2. So I can just pick a pair. So 0 to 4 is adding 4. And then 4 to 2 is subtracting 2. So I pick that pair, and then I have my change in y and I have my change in x. Change in y is -2. Change in x is +4. So we have the fraction -2 over 4, and we also do want to reduce our fractions. So we can divide our numerator and our denominator by 2 to reduce this fraction. -2 divided by 2 is -1. 4 divided by 2 is 2. So this slope is -1/2, so I know it's going downhill. So it's going to be a downhill slope. Another form of linear function that we have worked with is a graph. So when we find it from a graph, we also want to find our change in y over our change in x, but it's going to look a little different. Our change in y is going to be how much we rise or go up and down. And then our change in x is going to be how much we run or go left and right. So you'll hear me say rise over run a lot, and that's just how we calculate slope from a graph. So to do this, we're going to draw our slope triangle. So our slope triangle takes and connects us from 2 points on the graph. So we have these 2 points, and we can connect that diagonally, but that doesn't help me figure out a number because I don't know that distance off the top of my head. So we're going to make a straight up and down line. I'm going to start at this bottom point, and I'm going to go up to the height of that top point. So you can see that line is up to that other point on the graph. And then we're going to make a horizontal line connecting that line to the other point. So we connect the orange line to the other point. And now that we have vertical and horizontal lines, we can easily figure out how long and tall those lines are. So this purple line covers 2 squares, so that is the length of 2. So that would be our run. And this orange line covers 6 squares, so that would be the length of 6. You can also count the jumps, so we can go 1, 2, 3, 4, 5, 6. We know it's 6 tall. So our rise is 6, and our run is 2. Reduce the fraction, 6 divided by 2 is 3. And then we have to check, is it a positive slope? Are we going up the mountain? Or is it a negative slope? Are we going down the mountain? So if we look at our line, starting from the left, going to the right, we are going up the mountain. So it is a positive 3 for our slope. I would like you to give this last example a try, check your answer in Edpuzzle, and then move into your practice.